Everyone, welcome to another edition of the Coding Zeal stream. I am your host, Eric Guzman, Talk to Me Gooseman on the Twitches. And welcome. And today is another special stream where we are going to be learning something brand new that I am 100% not familiar with. Only heard in rumors about the elixirs. And I'm joined with Matti and Zan. A pretty loaded stream. This is going to be a two-part stream. We're going to be covering Elixir, and then after Elixir, we're going to be covering something called Phoenix that uses Elixir. So we're going to figure out what that is. But first, we're going to do an introduction into Elixir itself and what the heck Elixir is. And Matti, tell us how so for you guys, can you explain in your own words, both of you? I'm curious to hear in your own words for both of you what is Elixir? Tell me about it. And we'll start off with Matti because alphabetical order.
Oh, great. Well, I'm pretty new to it, and I'm coming from JavaScript, and I've done and Ruby and C#. So I come from like imperative or object-oriented world. So it was, to me, when I first saw Elixir, I didn't know what to make of it. But when I first saw it, what it looked like to me was Ruby but functional, and so and you don't drink it. So I'll let Zan build off of that.
Okay. I'm glad I got that out of the way.
Yeah, so I also primarily use JavaScript and Ruby, but I definitely so Elixir is a functional language. It's dynamically typed. The inventor Jose Valem, he borrowed some of the syntax of Ruby and then built a maybe more developer-friendly language on top of an older language called Erlang. And Erlang's, I think, like 30 years old, maybe. And it's a language that kind of prioritizes scalability, concurrency, resilience, immutable data structures, which is always something that you see in functional programming languages. Yeah, and I think I had already had some interest and experimented a little bit with functional programming. And so like coming from and then like working with Ruby during the day, it was definitely a nice marriage of the things that I was interested in and familiar with. And I think like on top of the strengths that it has in regards to scalability and resilience, I find it to be a very enjoyable developer experience. It's some nice syntax. There's good support for documentation, testing. There's a pretty helpful interactive console that you can work with. Yeah.
So you touched on that it's a functional programming language. So why is that important for why is that such an important principle for Elixir? Why does it make it such a powerful language? Being I guess first of all, what is a functional programming language, and then why does it make Elixir so powerful?
So I think one of the reasons that you might use Elixir, if you were, say, for instance, coming from Ruby, even though they have somewhat similar syntaxes, in Elixir, data is immutable. So like in Ruby, some of the types of bugs that you might run into come from objects and classes kind of carrying around state. Mm-hmm. And in Elixir, you won't see that. Functions, everything is either a function or a module. And you can have side effects, but it kind of restricts you from having side effects or impure functions. So what I mean by that is a function for a given input will always have the same output. There's no internal state that might affect what that output is.
So how does one get started if they want to start using Elixir?
Yeah, so I think On the documentation for Elixir, you can find instructions for how to install it. And I think one important thing to note is that it's going to come, Elixir, like I mentioned, is built on top of Erlang, so it's going to come with Erlang, and then also the virtual machine, Beam, that compiles Elixir and Erlang down to bytecode. So once you install those, you will have Elixir, and then also an interactive tool called IEX to run Elixir,
Okay.
and also to like create and manage Elixir projects.
Okay. Great. So we won't be demonstrating installing stuff for the sake of the demo gods always do not shine down nicely upon us. So we'll be using VS Code Live Share and working off of Zan's computer. So, but it looks like it's as simple as doing kind of brew install Elixir, and that just gets you everything you need to run. So what's the first step? Like, what should we do to get started with? I don't know what to do next.
Yeah, so I think maybe the first thing we can do is just in the terminal, we can start IX. So now we have, can you see that on there?
Yep.
Does not, okay, cool. Yeah, so now we have an interactive terminal where we can start to write some Elixir. So Elixir is going to have a lot of the basic types that you expect from other languages like integer, float, Boolean, and like math will behave basically how you expect. Strings. I think there is also atoms, which are pretty important in how Elixir functions and modules communicate with each other. And those are they're essentially like constants. If you've worked with Ruby, they're similar to a symbol. They don't change, and their value is their name. And also something to note is that the atom is not the same as the string atom, but the atom's true and false are the same as the Booleans true and false. I believe that true and false behind the scenes are actually like bound to the atom.
Okay. Variable. How do you define variables in Elixir?
Yeah, so it works the same as you would expect in other languages. I think one thing to note is that because kind of at the core of Elixir, you don't want to be mutating data or holding state somewhere. Rather, data goes through a function and is transformed, and then you have data out on the other side. In any case, this that would usually be called assignment in other languages is considered more of pattern matching in Elixir. So like if you say, whoops. Oh no, I assigned it to 2. Well, I think we'll get more into this when we get into how pattern matching is used. But rather than assigning variables, you're kind of matching values on either side of an operator.
Okay.
So you're just saying that they evaluate to the same thing, basically.
Okay,
Yeah.
so we have to throw out our notions of doing an expression and assigning it to a variable, and to this concept of pattern matching is what we have to switch to.
Yeah.
Okay.
Yeah. I mean, definitely like syntactically, you can like say x equals 1 and then later say x plus 1. So you can use them like you would in other languages. But you'll see that like a lot of as we move through this, a lot of the operations, the way the language is structured kind of gives you ways of control flow where you don't have to do as much of that. You're more just like matching the shape of data rather than like storing a variable and changing it over time.
Okay, gotcha. Okay, do we in Elixir, how do we do the basic kind of like hello world type of example?
Yeah, so I think maybe we can talk about using functions. So we can define a function by itself. Let's see. I think I do not need parentheses if I'm not giving an argument. And this is just going to return hello world. And now I can call that. Oh yeah, I got it. Cool. So that's one thing that I forget is that when you're calling a function that you've defined by itself, you do need that period to call it. But then most of the time, you're actually going to be defining a module and then defining that function on the module. Yeah, I did. So Mix is the build tool that you use for Elixir projects. Right now, we're not actually inside of a Mix project. We're just in a directory that has this Elixir file. You see.
So Mix is kind of like npm where it'll run scripts for you, but it also initializes new projects. So it's kind of a little bit more like cohesive if you're coming from the JavaScript world. Mix kind of does all the things.
So like if let's say we're going to create we want to do like a hello world project. So the easiest way for me would be maybe to use Mix to initialize a project. Yeah. Okay. Yeah. So let's try doing that.
Yeah.
Cool.
Yeah, so you use Mix to compile, run tests, run tasks, and it's also a generator. It's got all
Mix
the things.
included as part of Elixir, or is there a separate utility that you have to install?
It's included as part of Elixir.
Okay, so it's just like a core integral thing. Okay.
Mm-hmm.
So we just did Mix new hello world, and that created a project called hello, or a folder called hello world. Cool.
Correct. Yeah, and what that is going to have is this.
Sorry, Nate is asking if Mix also makes waffles.
Yes. To answer that, yes.
It's really the best thing about the language. So this mix.exs is where you're going to you can configure your Mix project. There's a lot going on here that kind of says like what version of Elixir to run with, the different applications that you might have inside of it, because you can have different Elixir applications inside of there. And then at the bottom you have your dependencies. We can come back to this once we add a dependency. But you'll notice that in the structure that it's set up, there is a lib directory and a test directory. So right now it's gonna, if we can start an interactive session with Mix, and it's gonna compile everything in the lib directory for us. So there's actually already a hello world inside of it. So
I just want to take a moment. So the Mix EXS, when you were talking about just a little bit, that almost sounded like a package JSON file for like npm packages, right?
Yeah.
Okay.
Very much so.
Exactly. I wanted to make one note, and if you notice the file extension .exs versus .ex, that's pretty important. The .ex those are compiled, and the .exs, those are like scripts that you'd run. So the .exs will not be bundled with your application. So a lot of the times you'll have like runtime, like if you have a test task, that would be an EXS. You wouldn't have a .ex for that.
Okay. And then Dr. Argus has a quick question about that. Is running IEX without Mix basically running IRB instead of running Rails C? So IEX-S mix is like running Rails C.
Yeah. Yeah. It's pretty much exactly like that. Or like if you just run IEX by itself, you're just getting kind of Elixir without any of the packages from your mix project or anything like that. And then when you run IEX-S mix, it compiles all of your modules along with all the dependencies that you have.
Okay.
And that's super important for debugging if we were to talk about that later on, right, Zan? In terms of how you would break into your code potentially or debug in.
Yeah, that's another interesting thing when we do get into Phoenix is like you can run, I think the command is like IEX-S Phoenix serve, something like that. And you can have your server running, but then also have an interactive session inside of it.
Okay.
But yeah, let's go ahead and try to run IEX-S mix now that we have this mix project. And our hello world module will be here, and we can call hello world.hello.
And
it gives us back world.
Okay. So and the output says that we generated hello world app, and then does some Elixir. So it immediately threw us into the REPL, scoped into the project. So and then we were able to call. I guess they're called modules because I'm like inclined to go with like classes or whatever, but they're not classes, right? They're not these type of things.
Correct.
They're just modules. And what's
Yes.
so if you were to tell somebody like to conceptualize like what a module is for versus I guess like a class, because classically, when you go through college and you go to classes, it's all about object-oriented, class-based stuff. But we're not in object-oriented land anymore. We're in functional world, right?
Correct.
So modules play a different role, are different for that reason. Is that or
correct?
Okay.
So I think maybe I'm trying to think of a good example of that. Like I think in Ruby, when you do string manipulation, you have like hello world, and you might say hello world dot split. And so the string itself is an instance of the string class that is implementing split, whereas in Elixir, you would call the string module, and you would say string.split. And let me actually let's make sure I have the order of the arguments correct. Okay, cool. It's string and then separator. So you would pass it the data rather than it being called off of that string.
Okay.
So they are a way of code organization, but they themselves, modules, don't carry around any internal state.
Okay.
Somebody put that that kind of made it more clear, maybe clear for Mud for you, but rather than encapsulating state in classes, state's encapsulated in like processes and tasks.
Right.
And then you can run concurrent processes and tasks and have as many of those as you need to run your application versus having like 1,000 instances of classes.
And this kind of goes back to why Elixir is good, because it's small and easily can be parallelized.
Yeah, I'm trying to think. I guess next we could talk about more like higher level data structures.
Yeah, that'd be great. So we learned the basic stuff, the common other ones that other languages like arrays. I guess I know arrays. So what else is there?
Yeah, so there's actually kind of a few different structures that serve the purpose that arrays might serve in other languages. There is a list which looks a lot like an array, which is, I think, what you would use if you're using an array most of the time in other languages. And that's got square brackets. There's also a keyword list, so a keyword list has keys, and the keys can be duplicated. And something you might use this for is like the Postgres wrapper in Phoenix Ecto, when you're using where clauses, will use keyword list so that you can have multiple where clauses. So you could be like where, so you could have the same key and not be unique. And then on the other side of that, you have maps, which are also key value pairs, but these are unique. So like if you overwrite a key, or if you add the same key, it'll overwrite it. And then there are also tuples, which are similar to list. They are wrapped with curly braces rather than square brackets. I keep typing OK because what they're used for a lot is that a return from a function will be like a status, like OK or error, and then it'll be the value that you actually get back from it. I'm trying to remember exactly what they like, the advantages of both of them. I believe that lists you can insert elements faster, but then tuples are constant, so you have to like copy the list over. So they're getting things like the length is faster, but then inserting and removing elements is slower.
So like lists are mutable, like they can you can modify them and add to them, but then tuples are immutable, so it has to copy the data every time you try to mutate it, I guess. Okay.
Correct. Yeah.
One thing that I was confused about was when I'm writing functions, say in JavaScript, I know exactly how I want to write the function. If there's 2 arguments, I'll do 2 arguments. If there's any more than that, I'll usually use a JSON object, right? And so what I found out with Elixir is that the keyword list is actually used a lot when passed to functions, and it kind of helped me because it also kind of looks like JSON. So that's something to note too, is that the keyword list seems to be preferred as the data structure to use in your function declaration.
If we were just doing like hello name, then this is how string interpolation works. We could just do that, and I'm going to type recompile down here. Now we have an updated copy of hello world.
Curious if interpolation works with single and double quotes in Elixir? I know that's different in Ruby.
Yeah, I don't think so.
Well, it makes waffles, so it might do this.
Didn't get any errors.
Oh, it does.
Nice.
Okay,
yep,
so
makes
is
waffles.
there? Okay, just out of curiosity, so that's really cool that you don't have to worry about that. Is there any difference in a single quote and a double quote screen, like strings, like in Ruby? Do you know that while you're working on that, Dr. Argus is calling out that there might be a subtle difference between single and double quotes. He has an example of doing an inequalities check between the letter A, single quote A, and then the number 65, which I'm guessing is, the was it the Unicode? Or I forgot the code for A, I think, keyboard code.
Okay.
Looks like he wrapped it in a list, the 65 in a list. Oh, so double quotes.
Interesting. But then if I
So he's saying double quotes are what
go ahead.
considered a normal string. They're called binaries in Elixir. Single quotes denote a char list, which are numeric representations that happen to map to other things like letters. Okay.
Last try.
Nice.
Sweet. Okay.
So this is this runtime error. This looks kind of like a map, and it behaves similarly to a map, but it's another data structure called a struct, which is a way of defining a map with an expected shape. So that, for instance, if you try to pass that struct to a module that can't work with that struct, it will give you back an error, or rather a function.
So you might want to use them if you want
Okay.
type safety.
Yeah, exactly.
Yeah.
Yeah, and I think maybe so. One of the kind of going into what data structures can be manipulated by what functions. One of the powerful features of Elixir is that it comes with a lot of operations on collections, like modules for transforming collections of data. And so, for instance, the ones that we looked at earlier, list, keyword list, map, those are all examples of enumerable. So there is the enum module, which can operate on all of them. So rather than having different implementations of maybe something like map on different classes, you have one module that knows how to work with several different types of data. Yeah. So let's see. Actually, I'm going to do this in here. We will take a collection of names.
So this is starting to look a little bit like the syntax like in JavaScript, where we're mapping, we have this item, we're mapping over it, and then we have this callback function that is our processing function. Looks like to me.
Yeah. All right, so this, we can definitely run it with a list.
Oh whoa! I can see the documentation for enum. I hover over it. I don't have anything Elixir related installed on this computer, so it's amazing that Visual Studio Code's pulling up this documentation, probably from your computer, and showing me what enum is, and I can see the documentation. This is amazing. Okay, sorry. Okay, so we recompiled, we ran hello, and we passed it into lists with all three of our awesome names. And then what did it do?
So right now I'm just printing the list. I'm not doing anything with them. But then I was going to pass it a map instead. Actually, I do believe that if you pass it, I think if you pass it a map, well, we'll see what happens. I think it may be key value instead of just the value.
And then this IO module is a special module to just to output to input and output if we're going to be printing out anything to standard in, standard out, or
correct. Yeah,
okay.
Yeah.
Let's see, what does the error say? Protocol string chars not implemented for Erik.
Oh, yeah. So let me add this.
Some pattern matching.
Oh, because since because the object we're so what type is that we're passing in right now? I forget. The one with the percentage in front of it is a.
It's
okay.
a map.
Because the one without the percentage is a tuple. And the one, okay.
It's a tuple. Yeah, and so what was happening down here is that actually, when it's mapping over a map, what we receive to the callback function each time, instead of just the value like we did with the list, we're receiving a tuple that has the key and the value.
Okay. Let me scroll down.
So
two arity called with one argument. Does it just give the tuple? Oh, I'm just curious.
Say that one more time.
Two arity 2 called with one argument. Erik. Okay.
Looking at this, should we describe arity real quick for those that?
Yeah.
I mean, looking at this, like you see those functions, and then there's like a slash and then a number. That was weird.
Yeah. So this the like slash and number at the end of each of the functions says how many arguments it expects. So for instance, we have this function in I'm not sure what module this comes off of, but it's like in the global scope in IEX, or it's just available here. We can call exports, and then we'll pass it the enum module that we're working with, and it's going to list all of the functions in there as well as the arity of them a little bit. Arity is the number of arguments that a function expects.
Yeah.
So I ran the command exports, which tells me all the exported functions of a module, and passed it the enum module.
Okay.
And it printed out all of the functions, including their arities. So some of them, some of the functions have the same name but different arity. Like for instance, there's a max1 and a max2, and that essentially within the enum module, there'll be a function called max that expects one argument. Actually, let's see, max1 and max2. Yeah, that expects one argument, and then another one that expects two, and then you can define the function multiple times in the module, and whichever one the shape of the data that's being passed to it matches, it will invoke that function.
Okay. So this is the concept that if you know Ruby, you don't come across this because Ruby doesn't do this, but like in languages like Java, it's function overloading, I think is the term.
Right. Right.
So it allows you to, instead of writing one function and then having like a long list of variables and trying to check for did this variable get passed in and do this behavior, you can just define individual functions based off, I guess, the arity is the term.
Correct. Yeah.
It'll do that behavior, so it leads to more cleaner code instead of having to throw all this logic into your one function that must do it all.
Yeah, exactly. Like instead of saying like if this instead of having to do null checking and be like if this argument is available, go do this thing. If this argument is available, go do this other thing. You're able to just change the control flow based on which data is passed to it.
Zan, to build on that, and I don't want to get too much in the weeds, but can't you build on that with an annotation to say, hey, this might have the same arity, but when it's a float, do this, and when it's an integer, do that?
Yeah.
That's where it's like, ooh, you can't do that with overloading, like in C# or JavaScript. You can actually say, this might have two arguments, but one of them is a float, do this, and when one of them is an integer, do that. Or when one is a string, do this.
Whoa.
Yeah. Or just one name is Erik.
Actually, I'm going to shorthand this a little bit.
Oh, that's syntax. When something, do something? What? What is this language?
Wait, we should, let's see, can I get rid of this?
Okay. That's interesting.
So I actually don't know what's going to happen right now if we pass it a name that's not defined.
Oh.
Yeah, it's going to tell us like.
That is a really awesomely detailed error message. It's like telling us, I couldn't process this. Wow. Okay. That's something else.
Yeah, it's definitely super handy when you're working with like the predefined modules that come with Elixir or any package that you bring in. It helps you track down stuff a lot more quickly. And then to handle that case, we can just define a function that doesn't have a guard on it. So what it's going to try to do is it's going to, it doesn't matter the order you define them in the module, because it's going to start from the top, and the first one that it matches on is the one that it will invoke. So if we just define one that's the last one that doesn't have a guard on it.
Wait. This is like having to like create a function and like do like a switch case statement, or like one of those horrible if else. You don't have to do that anymore, at least in Elixir. You can define functions with condition that it only executes, when certain conditions are met, and then it'll just do that. And then if not, have a fallback function. Same way.
Yeah, correct.
Okay.
Correct.
That's cool.
And yeah, so this should run that. I think another thing is that like you don't need those. These guards are one way of doing it, but then it also will match on the shape of data. So we could say like, if there's no data there, then match on this other thing. So yeah, there's definitely a lot of flexibility in using that as a control structure.
Do hello foo and just regular old hello anonymous.
Oh, sorry. Thanks. Yeah.
And you can do hello with nil in it, so then you can handle a null case without having to do null checks anywhere. Just hello nil, and if you ever call hello with a nil argument, it would just do that. So it handles nulls really well as well.
I thought, because it's doing the do empty.
Yeah, well, it's seeing it as a value versus nothing being passed to it. So I think we would have to say, let me see if I think there might be an is nil check. Yeah, that'll work. So in that case, we would say when is nil name. Actually,
I believe you could just put nil where name is, and then it would just hit it there. Either one would.
Yeah, I believe you are correct. Oh, we should change this so we can see where it's going.
Hello, nil. Cool.
Yeah. Then if we did want it to have the same behavior, we can just call this first version. So that you can actually like reference the different versions of functions defined on the module within itself.
Huh. That's all. What would you call this? Like, is this like function overloading? Is there a special term in Elixir for what we're doing here?
Well, so when we're looking at the shape of the data, figure out how. I actually don't know if there's one specifically for adding functions of the same name to a module. But just in general, this is that idea of pattern matching that we were talking about before. And yeah.
So we were learning about pattern matching this whole time. You just didn't tell us.
Yeah.
So what else can we do with pattern matching? Like, is this? So I hear. I mean, one of the main things when we were talking about in the beginning of Elixir was pattern matching. So I imagine pattern matching is one of the most, seems like a very powerful thing and selling point about Elixir. So what else can we do with that?
Use cases. I mean, one of the like real world things that you will often see is that, let's say you're like working with a third party API, and you're getting a response back from it. Let's see. Then you could actually look at, or let's say that like you're talking to a different function in your application, and that function, it might return the atom OK with some value. And then let's see. Let's just say that if it looks like that, then we're going to call something called process value. But then it also might return an error, and then you can use it to instead do whatever logic you need to do to handle that error. So I think that's one kind of real world or like in web development, a common use case for it. Another thing it's handy for is recursion. Since you can refer the same function, but it's going to match on different arguments, you can change arguments as you recursively call something, and either like deconstruct or build up some result that you're working on.
I have an example of recursion, unless you have one, Zan, that I could show real quick.
We can use yours.
Just to demonstrate that point. Cool. I am in the live share. If you don't mind, I could create a new file.
Sure.
I'll just go ahead and create a new file and call it recur.exs. There it is. So I had it, in my clipboard here. I did not type that fast, just to be clear. So this is a module that I called Recursion, it has two functions in it, and you see the functions are called sum, and they each have an arity of 2. And this is I'm still new to Elixir, but this pipe operator is basically splitting a list and taking the first item, and then all the rest is going to be in the tail. So this is tail recursion. And so what it allows me to do is this right here will match any list that has more than 0 items in it. And so it will take that first one in the list and assign it to head, and then tail will actually be a list of the rest. And so the accumulator is something that's getting passed in, and here's the recursion. I'm calling sum, I'm calling it with the tail, which is whatever's left over in that array, and then I'm taking the accumulator, which is just a value, could have been called whatever, I just called accumulator to be clear, and then I'm adding whatever value was in that item that we popped off right there. And so when you first pass this with items, it's going to go and hit this over and over, but once that list is empty, it's going to hit this function, and then I know that that's the end of my my recursion, and I want to output the accumulator. And so this is how you might call that. So recursion dot sum. This is just a list of numbers, and then this is my accumulator. And to run that, I just do IEX recur.exs. There you go.
Okay.
What just happened there? IEX. Oh, maybe I'm not.
You can also use mix. You can run mix run recur exs.
Let's try that. Mix run. Recur. Wait. Is this what's in this directory?
Yeah, it's
Are
right
we
there.
here? Recur. Huh. .exs.
Compiled.
Oh, it just compiles it.
Yeah.
Oh, you're also not returning anything from it, and you're not printing anything out.
It should be. IEX. Huh. I was just running this. That is strange. Well, let's see. Maybe if I just call it here, recursion.sum. Let's just try 1, 2, 3, 0.
Function.
It's undefined.
Oh no.
Huh. What is happening?
Maybe I think if you move, let's see.
Try a new terminal.
Yeah, we're doing. You're like you're trying to do.
This isn't going to be on mine.
Yeah, you're trying to do the commands through on Zan's machine. So
Yeah, I just realized that this is a live share. Huh. Well, that should have worked. Let me try that one more time. Recur.exs. Interesting. It just pops me into that. You know what I could do? Maybe.
double check you have the file saved. That's a good point. So Barple Pepkins.
Oh.
Thank you, Barple.
Yeah. Classic.
There you go.
Just
Put
classic.
that on the screen so everyone can see.
55. So the point of all of this is to save your file. I mean, so anyways, so there you go, 55. If we just, bump that down to 3, rerun it, there's 6. So that's a simple example. And let's see. Oh, yeah. Actually, I meant to start with a simpler example. So this had tail recursion. with an and here's another example just to kind of demonstrate the point. In here, if I were to run this, you see it outputs hello world 10 times, and that number is coming. So I pass in 10, it's going to hit. When n is less than or equal to 1, it's going to output this message. If n is greater than, it will output it, but then it'll call itself again, and then it'll subtract. So you can see there's no mutation going on here. That's the point, is like recursion is a tool to avoid having to mutate data, and allows you to also not have to iterate off of instances of things. So
Very cool. So the pattern matching and for our functions is a powerful tool, and in this case, a recursion is the perfect example for this. Is recursion often, just out of curiosity, have you seen recursion often used in Elixir for stuff, or is it just for demonstration purposes most of the time of the power of the language?
Zan has a bit more real-world experience, so he could probably speak to it. But I believe it's one of the foundational elements. Recursion in pure functions, not impure, pure functions, and currying and those kind of things are all functional paradigms that allow you to do functional programming. So yeah, I think it's a critical tool, but I'm curious to hear what Zan has to say about it.
Yeah, I mean, I think it's definitely used more. I've seen it used more than in other languages because the language supports it better because of this pattern matching, and then also because there aren't for loops as such. So I think some of the iteration that you might do in other languages can be achieved more easily through recursion in Elixir. I think also, though, in addition to that, like I mentioned, there are a bunch of modules that come with Elixir that are very helpful for working with collections of data. So another thing is that you wouldn't really use a for loop because you will have a module that can work with whatever, that can iterate over any iterable collection that you happen to be working with.
Okay.
Piping is a way of sending data into functions without having to, essentially like a more concise syntax for using functions to like create a pipeline of transformation for the data. So for instance, let's see, we get the final value. outputs accumulator. I'm trying to think of how to show this here. So maybe instead of outputs accumulator, we'll take our accumulator at the end and run enum.sum. And I think one thing to note is that sum takes an enumerable. Are you able to see the documentation that I'm pointing at?
I'll have to bring it up myself.
Or the reference?
I can pull it up.
Okay. Yeah, so it takes one argument, but we're not going to explicitly pass that argument here. It's going to get called, like this pipe operator is going to pass the result of, or rather pass this value into enum sum, and then we're going to further pass that value into the IOPuts function that we were using before.
So the pipe operator is, I guess, coming, like think about it in bash scripting. If you've ever used a pipe operator in bash, it's just taking the output of one thing and passing it to another function, script, whatever it is, to then execute on that.
Yeah, exactly.
I like the syntax of the pipe with the little arrow, as it's like saying like it's going this way. Like that's it's going to the accumulator and then it's piping it and going into enum sum. So okay.
Yeah. Oh, what did I do wrong here?
So enumerable.
This is so much nicer than
Oh,
like having to write functions that call themselves and wrap.
yeah.
It's basically what this is. It's a function that's wrapping another function that's wrapping another function, but it's flipped and then it's like passed down into a call chain. And it's so much easier to think about that way versus inside
Yeah.
out.
So looking at this, I like this error message. So it's saying that it's enumerable is not implemented because accumulator is a value. So it's not an enumerable.
Yeah, I was thinking accumulator was the array.
Okay.
Exactly. So let's, right now, we can just pipe this. So that works. I'm trying to think of any more interesting, like maybe we want to multiply everything by 2 and then sum it.
Let's see. Select. Are you still working on it?
Oh, no, yeah. So we're going to take the collection and we're going to pipe it into enum map and just map over and multiply it by 2. And then we're going to pass the result of that that new list to sum, and then it'll start doing its thing.
Is there a reason why sum is being passed the value 0?
Because we needed so behind the scenes, it's like it's going to be receiving our updated array, and then 0 is going to be the second argument that it gets. So it's going to start with that accumulator.
Okay. Should it be enum sum or just sum, or does it know?
Well, because we're calling the sum from
because
here
the method's
rather
right
than.
Gotcha. Okay.
Yeah, and actually that makes me think I need to get rid of this down here. But it says that the end on line 6 does not have a matching do. Oh.
We need some syntax highlighting here.
Recursion sum 2. Oh, I wonder if I do have to. It's not piping it into sum the way that I expected.
Yeah, Elixir. I don't have any Elixir plugins installed on my VS Code, so at least on what you're seeing, it's not seeing any highlighting. Operators, equivalent, steroid. Look at all these operators. Pipe compose, reverse chain.
Cool.
Got it? Okay.
Yeah. Yeah, I guess, Matti, did you have anything else you wanted to talk about today?
No, that's it.
So we call 2 times. So what's happening here is we're calling a recursion sum, or we call it, where was the 2 times call? There we go. There's a backtick. Unexpected token backtick. Oh.
Line 8. Yeah.
Times 2. And then we got 12. Okay. So we passed in 1, 2, 3. It got the collection. It piped the collection and then mapped over them multiplying by 2. So it would have been 1 times 2 is 2, 2 times 2 is 4, and 2 times 3 is 6, and then it would have summed them all together and gave us the result. I think I did that math correctly. Okay. Oh, and then we did the recursion thing. Yeah, that's right. That's why the number's larger. Okay. There we go. Okay, cool. So the pipe operators are really nice too, and like I think you were talking about a different library or something that's very similar to this, Matti. Like another library that's similar to this that if you were curious about piping in JavaScript.
Yeah, so that one I used heavily in the past year. It's called Ramda.js, and it's in the same spirit of functional programming and allows you to pipe or compose functions together in a call chain. And it has just a whole slew of different functions for strings or arrays or objects. And they have the standard, map, reduce, each, flatten, but they have some pretty neat ones that allow you to kind of mutate, or not mutate, but evolve. Evolve is actually the method name to evolve your each one of your items, or not items, but like in an object you might have name and you might want to uppercase it. You could evolve it with a custom function. And but yeah, I don't want to get into the weeds with it, but you can see all those functions. Those are all the ones that you can basically pipe together. Pretty darn cool.
It seems like.
And this.
Oh, go ahead.
Yeah. I was gonna say that was part of the reason why I got so much on the functional train, was going through this and coming from an object-oriented world. It really there's a bee. Made me appreciate it. Yeah, just a quick, unrelated to that, but related to what we were doing over there, we didn't mention that you can have private methods, something that we should note, and it's just defp. So if you have a module and you don't want to expose, like how we've been going through this is we'll create a module and then we'll call like the module name .sum, but say you don't want someone to be able to call that, you would just make it a defp, and then it's not protected, it's a private. There's no protected as far as I know, because there's no inheritance or anything like that in Elixir, just the private.
So
method.
There's no inheritance. Yep. Is there the concept of, I guess we're going to cover this next week, but I guess the concept of includes or imports. Because I'd imagine since there's protected, there's a concept of including another module and your module but okay.
Yes.
Yeah.
You can use them in different ways.
And I'm pretty sure when we get to Phoenix, we'll see that a lot more.
Yeah.
Awesome. That's super
Definitely.
cool. Yeah, thanks so much for the intro to Elixir. It's definitely a change in the mindset you have versus, more popular programming languages. I'd imagine looking at this, I can already see like a different way of thinking when writing your own code. Have you had any kind of like benefits to the way you see the rest of your code once you started writing Elixir?
I have, for sure. I think it's not that I if I'm in an object-oriented language, like I'll use object-oriented concepts like inheritance, but I do try to avoid mutation and think about race conditions a lot. I think race conditions are one of the most annoying things to track down, and some of the hardest, and that's one of the benefits to using a system that's written with pure functions with state, is that there is no race conditions. So I think I bring some of that back to the JavaScript world or the Ruby world whenever I'm in it.
Yeah, I think maybe another thing as well. I feel like it's pushed me towards keeping modules or classes smaller when I'm writing in Ruby or JavaScript. Yeah, I think because you're always like, I don't know, there's something about always calling functions off of modules that I feel like when I've worked with Elixir, I tend to keep modules smaller and have a smaller focus. And it's definitely, I feel like, influenced.
Right, got that done. Mission accomplished. Win. And we're ready for the next stream next Friday. Okay, everyone. So next Friday at 1 p.m. Pacific, come hang out again. Come with your questions. Come with your questions, comments, or anything like that if you wanna partake. And we're gonna dive into Phoenix and try to learn about why Phoenix is awesome. So Elixir's awesome. So I'd imagine Phoenix is going to be more awesome. So I love to find out more. And yeah, so come join with us. So yeah, thanks everyone. And so say bye to Matti and Zan. You want to say bye too? Wave. Yay.
Bye bye, y'all.
Thanks for coming. See you next time.
All
See
right.
you next week.
And